two different equations. The first one is x raised to the power of 3/4 is equal to 125. We want to solve for x, so we want to get x completely by itself and somehow remove this power of 3/4. One thing I want to recall is if I multiply a number by its reciprocal, in this case if I multiplied 3/4 by its reciprocal of 4/3, that product is equal to 1. These 4's divide out to 1 and these 3's divide out to 1. So what I want to do here is take both sides of this equation and raise it to the power that is the reciprocal of 3/4. So in this case, to the 4/3 power. So if I raise the left side to the 4/3 power, I'm going to raise the right side to the 4/3 power as well. When I have an exponent raised to an exponent, or a power raised to a power, those are going to be multiplied. And as I already mentioned, 3/4 times 4/3 is equal to 1. So we have x to the first, which is the same as x, is equal to 125 raised to the 4/3 power. Now I've written a couple items here on the left side of the board, and I want to take a look at this second one. It says if a is a real number and m and n are integers, then I can rewrite a base of a raised to the m over n power as the nth root of the base a raised to the m power. And that's the idea I want to use here. So I have x is equal to 125 to the 4/3 power. And I'm going to use this idea here. The denominator of this exponent is 3. And that denominator is what I'm going to put in the index of the radical. The base is 125. So this is the cube root of 125. The numerator is what I'm going to put in the power. So when I evaluate this, I'm going to first take the cube root of 125. The cube root of 125 is 5. And now I'm going to raise 5 to the 4th power. And that will give us 625. So in this particular problem, we find that x is equal to 625. I'm going to come over here and I'm going to solve the second equation that I wrote, which is x is equal to the -3, or x raised to the -3/2 is equal to 1/8. I'm going to use this idea. If we have a and b as real numbers, and I have a fraction here, a over b, raised to a negative exponent, I can take the reciprocal of the fraction and raise it to a positive exponent. I want to apply that idea here, where x is raised to a negative exponent. The base of x is currently in the numerator. I want to take that base of x and I want to put it into the denominator and change the sign on the exponent. So from -3/2, I want it to be positive 3/2. I don't have anything else left in the numerator, so I'm going to go ahead and write a 1 there. So I have 1 over x to the 3/2 is equal to 1 over 8. So here I have a fraction is equal to a fraction. One approach that I can take is to cross multiply in this direction and this direction. So 1 times x to the 3/2 is x to the 3/2. And 1 multiplied by 8 is 8. Now again, I'm going to use the idea that I used in problem number 1. I want to remove the exponent of 3/2. So I'm going to raise both sides to the 2/3 power. 2/3. Keeping in mind that if I multiply these, if I have a power raised to a power, 3/2 multiplied by 2/3, those are reciprocals of one another, and that product is equal to 1. So in this case, I'll have x to the first power, or x, is equal to 8 raised to the 2/3 power. And at this point, I'm going to evaluate this expression, 8 raised to the 2/3 power, and I'm going to use this idea. If I have a base raised to a rational exponent, I'm going to take the denominator of that rational exponent, which is 3, so I have the cube root of the base of 8. I'll evaluate that and then raise it to the second power. So we have the cube root of 8 raised to the second power. The cube root of 8 is 2 raised to the second power. 2 times 2 is 4. And in this problem, we find that x is equal to 4. So there are 2 examples of solving rational equations.